Hello everyone, welcome to AJJ Engineering. Today I would like to discuss with you range of plastic under mold technology. Introduction. A plastic is a synthetic polymer of high molecular weight composed of repeating organic chemical units. Polymer is a single large molecule formed as a result of the union of two or more molecules of similar substance. Plastics are broadly classified into 1. Thermoplastic, 2. Thermosetting resin. Thermoplastic resins consist of long molecules each of which may have side chains or groups that are not attached to other molecules. That is, they are not cross-linked. Thus, they can be repeatedly softened and hardened by heating and cooling. Usually, thermoplastic materials are in granular form. Heat softens the material so that it can be formed. Subsequent cooling hardens it to the final desired shape. No chemical changes take place during forming. In thermosetting resins, reactive portions of the molecules form cross-links during polymerization. Once polymerized or cured, the material cannot be softened by heat. Normally, they are available in powder form and are cured in the mold at high pressure and temperature. As technology progresses, the line between thermoplastics and thermosets have become less distinct. More and more processes are developed which make us use of the economic processing of thermoplastics and then converting the material into a thermoset. Extruded polythene wire coating is cross-linked after extrusion chemically or by irradiation. The polythene is covered to thermoset materials by this process. It cannot be melted by subsequent heating. Materials and machinery have been modified to provide the economics of thermoplastics processing of thermosetting material. Example: injection molding of thermosets. Some plastic materials are member of both groups. Example: thermosetic polyesters and thermoset polyesters. Thermoplastic. Commercial grade of thermoplastics materials are in granule form. The material is granule form is converted to homogeneous plastic state suitable for injection to take place in the machine. This process is known as plasticizing. The shape and size of the individual granule differ according to the type of material. The particular form of granulate is detected primarily by processing requirements. They are also depend upon the production technique during manufacturing. The nature of the material should be such it can be easily plasticized at a temperature within a practical range to a homogeneous melt to permit even filling of the mold cavity. The material must be stable under temperature changes. Chemical decompositions should not take place during processing. The material will deteriorate 1. If it kept inside the cylinder at normal temperatures for too long a time due to the stopping in the cycle. 2. Exposed to high temperature inside the cylinder. Thermoplastics of low thermal stability will quickly show signs of decomposition. This is known as burning. The degraded material may run through the product as streak. A completely clean, free-running granulate without any tendency to agglomerate is the most important requirement for optimum processing. The size and the shape of the granule should be such that melt conditions are obtained. A constant bulk density of granulate is important on machines where volume feeding is employed. The nature of the surface of the granule should be such that absorption of moisture will be maintained at a tolerable level even during lengthy period of storage. A high absorption of water leads to the production of steam in the heating cylinder. This leads to the production of faulty product. Many plastics require intensive drying of resins before use. Bulk quantities are dried in drying chambers. It can even discolor the product throughout. These effects are more apparent in transparent or light colored plastic. Thermal instability in the material may separate out the chemical components in the plastic. These chemicals are often corrosive. They may attack the interior of the heating cylinder and the mold. Poisonous gases which affect the operator may also be formed. Ingredients are added to the material to alter its color and other properties. This substance includes dyes, filters, plasticizer, dispenser, substance designed to increase the adhesion of the pigment dye, and materials to aid free flowing property. These materials should possess the same thermal stability as the bulk material. They must be free from constituents which evaporate during processing. For the product to be of uniform size and shape, the material must exhibit small and even shrinkage on cooling. The material passes through 3 different stages. The change from one stage to the next stage is not sharply defined owing to differing length of the molecular chain. When softening temperature is reached of the material passes from solid state to thermoplastic state, the intermolecular forces are further reduced. When the melting temperature is reached, the molecules are completely mobile and the material will be in a thermoplastic state. Thermoplastics are further classified by the degree of order within the polymer overall structure. Amorphous plastic. They are rigid glass-like material. In A means not and morph stands for order. So amorphous is a material without any order or arrangement of molecules in the structure. They may be short-range order in some material. Example: PMMA, PC, ABS, PS, PVC, and UF. Crystalline plastic. Crystalline plastics are fiber-forming material. They have regular arrangement of molecules in their structure. They are always characterized by their long chain of molecules. Example: PP, PTFE, PET, and P. Difference between crystalline plastics and amorphous plastics. Comparison between thermosets and Some important plastic material. On the second column, we can see the resin generic name, and on the third column, we can see its abbreviation. Some field-wise application of plastic. For automobile field, for building construction, even for chemical. Medical field, textile field, packaging, electronic or consumer application,